I am Dr. Ramkrishna Ghosh, an Associate Professor of the Department of Information Technology of Haldia Institute of Technology. I am going to discuss Introduction to Operating System today. Now question arises, what is operating system? Operating system is a system software which realizes effective utilization of computer system resources, both hardware and software, with respect to time in a given computer environment and to provide an interface between the user and the hardware so that the user can use the hardware resources to solve their problem. There are two types of software. Software is actually a set of programs, rules, associated documentation, and data. There are two types of software, system software and application software. System software, example, operating system. Microsoft Office, Paint are examples of application software. The relationship between system software and application software is that system software monitors application software, which makes it usable. The primary purpose of operating system is to make the most efficient use of hardware resources. The primary job of operating system is to manage resources. Operating system is called the overseer and supervisor of all computer activity. A computer cannot boot if it does not have operating system. Operating system performs all the housekeeping functions. Booting is a process of switching on the computer and starting the operating system. There are two types of booting, cold booting or hard booting. When we start a computer, it happens. Another type of booting, warm booting or soft booting. It happens when we restart a computer. Booting includes 6 stages: BIOS and setup program, basic inputs output system, BIOS, post power on self test, operating system loads, system configuration, number 5 system utility loads, and number 6 user authentication. When the power is turned on, it sends electricity on the motherboard to the main components BIOS, processor. Then BIOS runs power on self test to check all the hardware components, input output devices, storage, memory, CPU are running properly or not. If any issues found, it warns the user with a beep or error codes on the screen. Then BIOS looks for operating system. It loads the operating system into main memory. Then system configuration means device drivers and settings are uploaded into the computer. Then system utility loads. System utility means software that monitor, manage, handle computer are loaded. Volume control, antivirus, normal functioning of a computer are loaded. At last, user authentication. User authentication is the act of verifying the identity of a user before interacting with the computer. It is performed through user ID and password. Operating system has 4 important functions. Number 1, process management. Number 2, memory management. Number 3, storage or file system management. Number 4, input output management. Process is a program in execution. The execution of a process must progress in sequential fashion. At any time, at most one instruction is executed on behalf of the process. There are differences between process and program. Program is a passive entity. Program specifies the logic of data manipulation and IO actions. Program cannot do anything by itself. It has to be executed to realize the actions. Process is an active entity which executes the logic specified in the program. So, each process in the operating system is represented by a process control block, also called a task control block. It contains many pieces of information associated with every process. It contains process state. I will discuss program counter. It indicates the address of the next instruction to be executed. CPU scheduling information, IO information, memory management information, accounting information, etc. So, process state. It has 5 states: new, running, ready, waiting, and terminated. New means the process is being created. Running means the instructions are being executed. Ready means the process is waiting to be assigned to a processor. Waiting means the process is waiting for an event to occur, such as an IO completion or reception of a signal. Terminated means the process has finished its execution. When the process is admitted, it will go into ready state. When an interrupt happens, interrupt means is a signal that can stop the program in an operating system. Interrupt happens, process will go from running state to ready state. When scheduler dispatch happens, the process will go from ready state to running state. When IO or event wait happens, the process will go from running state to waiting state. IO or event completion happens, the process will go from waiting state to ready state. And at last terminated. The process has finished its execution. So process management functions includes creation and deletion of both user and system processes, suspension and resumption of processes, process synchronization. Process synchronization actually can be viewed as a set of constraints on ordering of events. Process synchronization is required when processes sharing data and resources. Process synchronization is used to prevent data inconsistencies, process deadlock, and rest condition. Process scheduling. It is an activity of determining which service request should be handled next by a server. In our computer system, CPU is the server and user jobs are the service requests. Process scheduling criteria. There are different criteria in an operating system for process scheduling. CPU utilization. CPU utilization ranges from 40% for a lightly loaded system to 90% for a heavily loaded system. Throughput. The number of programs processed per unit time by the system. Turnaround time. Turnaround time is the interval from the time of submission to the time of completion. It is the sum of periods spent waiting in the ready queue to get into memory, executing on the CPU, and performing IO. Waiting time. Waiting time is the sum of periods spent waiting in the ready queue. And response time. Response time is the amount of time it takes to start responding, but not the time to output that response. And process scheduling involves 3 subfunctions. Scheduling selects the process to be executed next on the CPU. Dispatching set up execution of the selected process to be executed on the CPU. And context save the status of a running process whose execution is to be suspended. There are 2 types of scheduling: preemptive scheduling and non-preemptive scheduling. Preemptive scheduling requires time slice and Non-preemptive scheduling time slice is not defined. Time slice is the largest amount of time any program can consume when scheduled to execute on the CPU. So non-preemptive scheduling examples are first come first serve FCFS and HJ shortest job fast. Examples of preemptive scheduling round robin scheduling. Next, memory. Memory is the information, is the device where information is stored. Memory management functions involves allocation and deallocation of memory, integrity maintenance, what belongs to whom. Swapping, important. Swapping is a technique of temporarily removing inactive programs from the memory of a computer system. It is done by middle term scheduler. And programs existing in memory can be classified into three types. Active programs, programs only one program executes on the CPU while others perform IO. Programs being swapped out of the memory, programs being swapped into the memory. Swapping is done by the middle term scheduler. There are two types of scheduler: long term scheduler and short term scheduler. Long term scheduler determines which jobs are poured into memory for processing. Short term scheduler selects from among which jobs are poured into memory for processing. The primary distinction between long term and short term scheduler is that short term scheduler executes much less frequently than long term scheduler. Short term scheduler executes at least once in every 100 milliseconds. Virtual memory. Virtual memory is a technique to ensure large logical address space to be mapped onto a smaller physical memory. It frees application programmers from worrying about memory availability. It increases the degree of multiprogramming. Number of multiprogramming means multiple programs are in memory concurrently and instead of execution. The main variable advantage of virtual memory is that logical memory can be larger than actual physical memory. Then file, storage or file system management. File is an abstract data type that can be defined and implemented by the operating system. From the user's perspective, file is the smallest allotment of the secondary storage. It is a sequence of logical records. It is a collection of related information on the secondary storage. Nothing can be written to the secondary storage unless they are written within a file. There are two types of file: sequential access file, random access file. Sequential access file is based on the tape model of a file. Information is processed in order, one after another, and it works like sequential access device works. And editors, compilers access files in this fashion. Random access file is based on the tape model of a file. It is a collection of fixed length logical records that allows to read and write files rapidly, that is in no particular order. So storage and file system management involves creation and deletion of files and directories, support of primitives for manipulating files and directories, mapping of files onto storage media such as disk, tape, etc., and backing up of files and directories. Now I am going to discuss types of operating system. Batch operating system. Batch is nothing but a set of user jobs that have similar hardware resource requirement. Inputs are given to the system batch wise, not job wise. Batch monitor system is an operating system of the batch processing system. So batch processing system is a computer system that allows a series of jobs in batches. One job is independent of another job. Best operating system examples: payroll accounting, banking system, airline reservation system. Batch operating system examples: IBM, OS 360. Multi-programming operating system. Multiple programs are in memory concurrently and instead of execution. Multi-programming operating system was developed to improve the performance. It allows more efficiently allot resources than batch processing system. Multi-programming operating system is a system software that allows multiple programs to be run on a single processor computer system. It changes from one state to another so quickly it gives an illusion to the user. The multiple CPU is involved, but only one CPU is involved in multi-programming operating system. Examples of multi-programming operating system: Linux, Unix. Multi-processing operating system is an operating system where multiple processors are used on a single computer system to increase the processing speed of the machine. Examples of multi-processing operating system: Linux, Unix, Windows Server. Multitasking operating system is a system software that allows multiple tasks to be executed simultaneously. Examples of multitasking operating system: Linux, Unix. Time sharing operating system. Actually, multi-programming was developed to improve the performance. Multi-programming operating system allocate resources more efficiently than batch processing system. Time sharing operating system is a logical expansion of multi-programming operating system. Time sharing operating system allows users from 1 to several hundred to access computer system interactively at the same time. Time sharing operating system examples: Linux, TOS, time sharing option, Unix. Distributed operating system. Distributed operating system is a collection of loosely coupled processors interconnected by a communication hardware. Distributed operating system is a collection of processors that do not share memory or a clock. That's why distributed operating system is a loosely coupled processor. Each processor has its own local memory. Processors can communicate with each other through various communication lines such as high-speed buses and telephone lines. Processors in distributed system may vary in size and function. Distributed system allows processors to access resources located at remote sites. Distributed system examples: mini computers, small workstations. The main advantage of distributed operating systems are resource sharing, reliability, computation speed up, communication. Next, network operating system. Network operating system is a system software that allows devices and computer on a network and allows them to share resources on the network. Examples of network operating system: Linux. Real-time operating system. Real-time operating system is an operating system that can provide a timely response to an application. It is a system software that allows multiple operations to be run quickly and on time. It can provide various benefits: creation of multiple processes within an application, priority driven scheduling, fault tolerance, and graceful degradation capabilities. Interrupt, pausing, routines, priority driven scheduling. Examples of real time operating system QNS and um, RT Linux. Thank you.